Hello guys, so welcome to another video on Blue Tech Empire Python tutorials. So in this video we are going to be talking about data type conversion. So data type conversion deals with converting from one data type to another. For example, converting from an integer to a float, from a string to a float, from a string to an integer, from a list to a tuple, or it's just about data type conversion. So we're going to be seeing the common data type conversion. We may not look at complex types, but we're going to be looking at common data type conversion. So let's get directly into the video. Yeah. So when we talk about Python data type conversion, like I said, it's converting from one data type to another. Python has various inbuilt methods for doing data type conversion. What are inbuilt methods? Inbuilt methods are methods you don't call in from a function or from an object. For example, let me show you an example what I'm talking about. So, for example, if we have L1 equals to a list 5, 8, 9, 6. Now, we can say len, all right, L1. It gives us the len of L1. Now, we said len L1, but let's say in case we want to sort L1, we're going to say L1 dot sort. Now, if we print L1, let's see. Now, this L1 has been sorted, as you can see, in ascending order. Now, notice the difference between the sort and the len method. The len takes the list as a parameter, while the sort follows a dot. The sort comes after a dot L1. Now, this sort is a method of the list object, while len is an inbuilt method. It takes a list as a parameter. We will later see how you can define your objects to work. When we learn about objects, we're going to see how you can create objects that actually work with the inbuilt functions, because the objects needs to implement some functions and that's one of the power of Python. They call it, I think, it has I've just forgotten how they call it, but function has an option. Python has an option which allows you to set up an object in such a way that built-in methods or operators is like overloading, method overloading or operator overloading, in which you can set up an object, for example, to work with a plus sign or the negative sign in such a way your objects can be added together or whatever. Yeah, it may sound complex now, but later on you understand what I mean. So here is an inbuilt method function, while here is a method of lists. Now, if you want to check out the inbuilt functions, you can first say dir like this, and you see it gives us a method or an object called inbuilt. Now, if you want to know if inbuilt is an object, you can write inbuilt. Built ins. See, it's a module. All right, so it's a module like a file. It's a module that contains a number of functions. We are going to learn about modules sometime. You see, it's a built-in module. So now, if you want to check the content of that module, we're going to use dir. That's like these objects, its properties, and so. Now, here are all the inbuilt models. We're going to be looking at some. For example, here are the ones we're looking at. Integer, you see int is here. All these words are reserved words used by Python, so you're not supposed to use them as variable names, or else you're going to replace these ones. So you see max, map, or power, print. Here is print, we used to always use. You have print. So print is a statement. You have quit, you have sum. Now here are all what we're going to be using is here. For example, I just want to show you so that you're going to see bin should be here. Yeah, bin is here. Oct. So I'm just showing you so in case you forget, you can know where to check from. Dir and built-ins. So you see oct is here. In fact, all of them are going to be here. This is not valid. Yeah, I don't know why I had this here. Unicar, for example, you can see there's no unicar. We don't have unicar here, but we have odd here. We have chr should be somewhere here. Yeah, chr is here. So frozenset is yeah. So every here is frozenset. So every stuff is here. Dict, tuple, str. So here is where you can get some buildings, but I just want to show you there's a difference between buildings. For example, look at our list L, and not all objects support these building methods. Objects must be designed in such a way that they have to support it. For example, let's look at dir of list. Let's see. Yeah, so here are some methods actually that help these built-in methods to be. For example, here is a greater than method that helps a list to be able to work with a greater than or less than sign. Also, such ge equal to, here is an equal to, yeah, here is a greater than. I think here is a less than method. Here is the len. Yeah, if you want the object to be able to work with the len, you have to define a Python specific method within your object. We're going to understand all that. For now, it may sound a little, so let me just leave it. So now let's say, for example, we have L1. Now you can say, for example, we want to find the sum of L1. We're going to use the sum built-in method, sum L1. You see, and you have to know L1 actually defined a method to help it handle sum. We're going to see all that later. I just want you to know that you can create a method that can work with you can create an object that can help the built-in method sum your object. So because of a Python specific variable function or method you define within that object. So let's just leave that for now, just for completion. So we can use something like the mean L1. Yeah, so these are built-in. You call them, then you pass an object as a parameter. In this case, the object is a list. But in the other way, you can also have objects of, methods of a particular object. For example, L1.pop. You see, this time now we are popping the last item from L1. But you see, we call the pop method on L1 object using the dot operator. So here is how you call a method from an object. So I just want to show that there's a difference between a built-in um, function and a method object, or an object method. Let me put it like that, an object method. An object method is called on the object. It precedes the dot, while a built-in method takes a built-in function takes an object as a parameter. It's not called on the object. For example, if you say L1 dot sum, I don't know if L1 has a sum method. Yeah, it doesn't work. This one object has no attribute sum, attribute or method. Yeah, so I just want you to know that's possible. So all the methods we are looking at for type conversions are built in, so they are within the built-in module. So now let's get to our type conversion. So let's see the first type conversion we're going to be looking at. What? This is not working. All right. All right, so let's see examples of integer. Let's start with int. So we can use the int built-in to convert an some value to an int. You understand? So convert x to an integer. Let's see if a string can be converted to an integer. Yeah, a string can be converted to an integer. For example, if we have let's say a string age, let's say someone gave his age in the form of 30, and we have it, or we obtained it from a file, so it's going to be in the form of a string. And let's find type as age, and let's convert it to an int. Age equals to int as age. So there we go. We have now we can find type age, and we see, sorry, and we see age now is an integer, so you can convert a string. It must be a valid integer. For example, if you have if you say int let's say 23d, as you see, it's gonna fail, so it must be a valid integer. All right, so that's how it works. Now you can also have a base. Convert x to an integer. The base specify the base of x if x is a string, okay, now we can say integer ff base 16. Let's see. You now see. Now we are trying to tell Python ff is an integer, but it's an hexadecimal number. You understand? So normally ff hexadecimal is base 16. Okay, so let me show you another example. Integer. Let's say 24 fb. Yeah, that's a base 16 number. Let's convert it to it's base 16. Let's convert it to an integer. You see, it gives us 900 and something. Now it can also be a base 8, but you know base 8 numbers don't have 8 within them, so they end around 7. So you can tell Python this is base 8, and Python is going to return something like this. Now let's see if it's possible to do that for a boolean. um 1010. Let's try to tell it is base 2. All right, so you see it works. 10 base 2. So it's just to understand. You can, for example, 111, or let's say 1111. Many ones, 8 ones is usually 255. Just so we know if Python is doing here. So it's 255. So you can do this to convert, and it's very important because if you tell the user, for example, to enter age equals to input, enter your age, like this. So if we press, let's make it better. All right, once the user enter an int, for example, let's say 40. Now if you say type age, it's going to give you string. It's always good to know when a user enters an input, when you collect an input from the user using the input inbuilt function, it returns a string. So if you want to use it like a number, for example, if you want to say age is, let me say, or you just want to use it like a number somewhere, like for example, you want to add 10. In 10 years time you will be this age. Maybe you want to write age 2 equals to age plus 10. You understand? You can't do it because what happens is when the user entered an input, when you use the input function, what happens is it returns an age, but it's in the form, even though the user typed a number, the output of the input command is always a string. That's why you see people always say int input or float input. They always put the input within as a parameter to the float function or the int function. So now we have to convert int. If you want to write that, normally we have to convert this age to an int like this before we can now carry out those operations. So now if you type h2, please just take note of that. So if you want to do addition with integers with a valid string, but a valid integer string, you understand, you need to convert it to an integer before you can carry out any integer operation with it. That's why you see people always write, maybe someone can write age equals to input. It starts with int first, then now followed by input. It's just a short form of doing it the way I did it above. Enter your age. So here is a short form. Now input. So as you can see, this input function, whatever is returned will be converted to a string. Then this integer now will convert it to an int before sending it to age. So if you type like this and it enters 45, 43. Now if you say type age, you see it's an int because we converted it. So usually you see people writing this, or sometimes some people write float because they want it as a float. So I just want you to understand in case you see this in some code. My age 20 old. Now because they converted the age to a float, it's going to have a decimal point. So if you type age Yeah, so I just want to show you that now when using this something like this, if you want to specify a base, the value must be in a string. That's the first parameter must be a string. It can be, you can say, for example, you want to convert 345 to base 8. 8 will not work. If it's correct, but the first parameter must be in the form of a string, even if it's a number. I just want you to know that. So now let's move forward. Let's go to complex. Now you can convert any number to a complex number. For example, you can write complex 9. You see, it gives you 9 plus 0j. It adds this stuff for you because you may, and now you can now add it to another complex number. So you can say a equals to com equals to complex 9. Now you can say a plus maybe 5, or you can now say a dot conjugate, something like that. And you have all, so just all that I just want to show you, because normally you cannot have a conjugate of 9, but you may not use this if you're not into mathematics. You may not want to convert a single number into a complex number, or you can even use, it can even be a float, 9e3, 9.2e3. So it can be any, whatever you want. It can be what 9.23, whatever. So I just want you to know it can be a float like this, and so you can do that. All right, so let's move to the next. Complex xy creates a complex number from x and y. Now complex xy, you have both the imaginary and the real part. So we want imagine a real part of 9, imaginary part of 3. So let's see, you see 9 plus 3j. So you can just say, you can even call complex maybe one one you can say complex, let me close this. You can say complex 1 3. Let me show you now. Complex 1 3, let's say dot conjugate. Here's a bit of an egg, you see. So you type a, so you see 1 minus 3j. So the best, when you use two numbers, the first parameter is the real part, and the second parameter is the complex part. And of course it can be decimal points, like so. You can do whatever you want. So now the next one is string. Converting stuff to string, very common. You can convert every stuff to a string. For example, you can have the number 2, convert it to a string is 2. You can even convert a float to a string, 4.5. You can convert a list to a string. You can convert a list to a string. You can convert a list to a string. You see, it just converts in place. Even a tuple, you can convert a tuple to a string, and you can even convert a dictionary, even a set. You can convert a set to a string, and every stuff out there. And you can even convert a dictionary to a string. I just use name age. Dictionary can contain any stuff you want. I just use name age most of the time. And you can say, let's say, now let's use, all right, so you can convert any form to a string. Just know string converts stuff to string. And why can you want to use it? For example, you may have an age equals to, let's say, 32, and you want to write a string, maybe a sentence called welcome message equal to your age is, and you want to append it to plus age. It's going to fail. Why? Because you're trying to add an integer to a string. So usually you want to convert this first to a string before. Most times you always want to do this when you want to append a message. Now you see your age is 32. When you want to usually append something like a float or even a dictionary, whatever you want to append it to a string, you usually find that you have to convert that stuff first to a string, because you can't add a string and a number. They must be both strings before the concatenation operator works, or they must be both integers before the addition operator works. So I just want you to know that. Now, let's say, what about tuple? All right, so we can also do that with tuple. You have to convert something to a tuple. It must be an iterable. For example, let's see a tuple of welcome. You see, it's going to create a tuple. See, it must tuple. Sorry, tuple. All right, so it creates a tuple with WE. So you see, it must be an iterable. If you try to do it with a single number like this, let's see, we go, no, it doesn't go. You say object is not iterable, so it must be an iterable. We can also use a list, so we can form a tuple from a list, 2, 3, 4, 5, and you see, so we can form a tuple even from a tuple. Let's see. All right, so we can form a tuple even from a dictionary. Let's see our old dictionary here. All right, so we can form a tuple from this tuple. Let's see. All right, so you see, it just picks only, because I told you when you iterate through a dictionary from the last video, I told you when you iterate through a dictionary, you actually pick out the keys, not the values. So you see, it picks out the key name, picks out the key value, and it forms a tuple with that. Okay, so you can do that. It must be an iterable. So tuple converts a sequence or a sequence here to a tuple. Now list does the same stuff tuple does. You see, if you use list, you see, if you use list, you can even create a list from another list. All right, so list. There may be reasons why you want to do that. Always know there are always reasons why somebody may want to do something. It's when you start designing complex programs, then you're going. If you're just a beginner and you don't write a lot of programs, you can wonder why should I even ever do this? But programmers who write a lot of complex code come across all kinds of scenario where they need to apply all this stuff. So you can form a list from a tuple. You can even form a list from a dictionary. Like here, let's form a list. See, all right, so you can do all that similar, the same. You can do that with a set, but remember, a set can only have mutable. From the last video, a set can only have immutable items or hashable items. So let me show you what we've been doing. We can also do it with a set. So let's see, set. You see, it forms a set with welcome. But look, sets are very unordered. They always come out. They're always unordered. You understand? So you see, it's a mixture, even though it's never ordered in a particular way. You understand? So even when you use the pop, you can pop out random out item, because normally the pop pops out the first item, but with a set, since you're not sure of the first item, you cannot rely on the pop method. So I just want you to know that, you understand, for example. So now let's look at another way of creating a set. You can create a set from, like we explained, from a list. You can create a set from a tuple, and you can create a set from a dictionary. No problem. It's just going to pick out the keys. And no matter what you're doing, you have to make sure you don't have and when you're trying to create a set, make sure you don't have an immutable item within. For example, this is going to generate an error because we have attempted to create a set from a tuple, but there was a list in the tuple, and it indicates you want to put that list in that set, so it's going to generate an error. I just want you to know that. So now, one other stuff you should know is you can create a dict. But the difference between dict is you cannot just create a dict from items like this, because dicts need to have key value pairs. Sorry, I did not end it well. There's an error. Now, dict need to have key value pairs. That's where the challenge is. So the way to create a dict is that you must have a pair of a tuple with key value pairs. Let me show you what that means. Let's say here is our tuple. Here's our tuple T1. See how we build our tuple. A tuple normally is within this. We build it like this. or let's say a pair, a sequence. It can be a list too. So let's use a list, and then let's build our tuples. So we want to normally create three dictionary items, or let's say four. We want the first item to have a key name, and the value uh, here. We want the second item to have the key age and the value. Note that this is a tuple, so items have to be separated by comma, and the value 21. We want the third item to be let's say height. So the key should be height, height, and the value should be let's say 7.1. And we just now want to just do some crazy stuff. We want a key 3 and the value THREE. We want crazy stuff, like I said. We want a key to be a complex number, because dictionary keys can be any immutable type. So 3 plus 5J, and we want it to have a value complex. So we're just doing crazy stuff here. So let's finish our list. We made a mistake somewhere. Let's see and make sure everything is correct. So let's those normally these spaces are not important. I just want to make sure everything is correct. All right, I did not end this complex with a I had to end this complex. Let me expand this so you see clearly. Yeah. So I did not end this with a yeah. So I think it's cool here now. All right, now we have created a sequence of tuple key value pairs. You understand? A sequence of tuples containing key value pairs. So you see, this is a sequence. It can be a tuple, it can be a list, but you see, we have key value pairs in the form of tuples. Key value, key value. We can now use this to create a dictionary. D1 equals to dict D1. Now look at D1. It's our dictionary. We have name Michael, age 21, height this, 3 this, and 3 key 3. So you see the keys, we were actually creating key value pairs, key value pairs. I just wanted you to see that. So it's very important for you to know that. Very important. All right, so as you can see, you have key value pairs, key value pairs, key value pairs. So when you create a dictionary from D must be a sequence of key value pairs tuple. A sequence of key value pair tuples. You see, these are all tuples. This is a tuple with two items. This is a tuple with two items. But they are in the key. The first item should be the key. The second must be the value. Now they say a sequence, which means this can still be in a tuple. For example, we can still put this within a tuple by using. If you have not learned on dictionary and tuples, you can go to our tuple and dictionary video so you can understand what we're doing when we're talking about tuples and dictionaries or lists. So in this case, you can still say T1 equals to this, and you can still create dict from T1. So if you check T1, you D1, you see it still works. So I just wanted to show you that. Now let's move to the next frozen set. Now sets, like I told you, if you check the sets, you see a set can be, you can remove an item from a set, you can pop an item. For example, let's say we have the set S1 equal to, here's some values, 1, 2, 3, 4, 5, 6, 7. Now let's say we say S1, print out S1. It's always is this one times none, or that S1 dot pop. You see, we can even say S1 dot add, S1 dot add, I think is it add 3, or let's say 12. Okay, so you can manipulate S1. Now let's convert S1 to a frozen set. A frozen set converts a set to an immutable form, which means a form that cannot be changed. You can't, once you create a frozen set, you make a set to be immutable. Yeah, it can be important when you're doing some mathematical computation. You want this, you don't want removal and addition to sets because you really want to use them for something important. So in that case, you can create a set called S2. It should be equals to frozen set of of S1. Now look at S2. S2 is a frozen set. Now try to do those stuffs we're doing with S1 with S2. You see what's happening. S2 dot pop can't work. It's a frozen set. You understand? It doesn't even have the method pop. You can check his methods. Let's see his method frozen set. So it has union. You can carry out all the other stuff you carry out with sets, but now you can pop out stuffs, remove stuffs, or add stuffs, all those stuffs, all those other extra stuffs that helps you to change the size or that makes it mutable have been removed. So now it's completely immutable. You can only carry out normal stuff like S1 union S2. You can carry out all this stuff. It's still a set, but it's a frozen set, which means it's immutable. Now, let's see the other stuff. CHR. Now, CHR is also very important because um, CHR converts an integer to a character. What does that mean? It's not really like converting an integer to a character like the str. Instead, it uses what we call the RC character set. Here is a table like we explained. All characters in the keyboard represent a number. You should know that. So here are them. You see decimal, this hex, and here is the character. For example, let's see 32 represent the character 20 on the keyboard, or let's say no, 32 represent the 33 represent this character exclamation, 39 represent this, and all stuff. You see all these characters and their representation. Now let's convert 60 to its character. It should give us less than. So let's do it. Let's say s c h r 60. So it give us less than. I just wanted to see this is correct. So let's follow this. All keys on the keyboard have a character, have a number, a decimal representation. That's how the computer works. All characters are represented by decimal because the computer only understands numbers. So whatever character you type on the keyboard at the backbone of at the machine level, it sees a number. That's the work of the keyboard. The electronic devices of the keyboard carry out that conversion and send to the computer. So let's see 70, let's see for 90, CHR 90. You see it gives us Z. Here is it Z. See, so let's check the last one, CHR 125. CHR 125. You see it gives us this number. So whatever character you want, you understand, 25 should give us percentage. Yeah, CHR 25, CHR 25. Yes, it gives us the percentage, but it gives us in a form you may not be familiar with. It's in binary form. Yeah, but let's not really talk about that now. CHR 25, no, not 25, CHR, let's say CHR 36, CHR 36, 36, 30. Six. It was some kind of Unicode character. Let's not worry. All right. So there is it. You can use that to convert from one of these forms to the other. So I just wanted you to know that. All right. So let's move. Let's see. Now here are the last three: hex, oct, and bin. Hex is just to convert something an integer to hexadecimal. Like 15 should give us f. OXF, yes, it always has the 255 should give us OXFF. Yeah. Now oct is to convert an integer. Let's find 15 or 255. So it gives us OO, and the last one is bin. So all right, so there you go. You can convert an integer to any of this form. Maybe you're carrying out some kind of binary operations, for all those into mathematics and electronics, they can want to use this for a lot of stuff. All right, so there you go. So here are just some examples, quick examples on those. These variables, print, type, you can find the type. You can do all this, find the type. You see it's an integer. You see here, type this, it's a string. So here are just some examples of what we have been doing here. Here are some other examples of what we have been doing. Mm, So as you can see, print bin 300 converted this 300 to a binary, print hex 300 converted this to a hex, oct converted this to a oct, odd, like we haven't talked about odd. Odd is the opposite of CHR. I'm going to show you that. I missed it. Odd converts a character to its binary representation, while string converts a decimal to its character representation. So odd is the opposite of CHR. So you see odd, 2 in the keyboard, A in the keyboard, and I'm going to show you odd later. Now complex converts this to a complex. You see 3 3, if you say 3 4, you see is the real and imaginary part and all those stuffs. Print list converts, you see, converts to welcome as separate items of the list, while this 3 4 converts to first, second, and third. So I just want to show you print set. You see, to convert an iterable to a set. This hello, you see, it's not all that. This converts this iterable to a set, like we saw. You see set one, this set one dot add. We can add to a set, we can remove from a set, and we can print set one. But when we convert a set to a frozen set, we can do all that. We can add and do all those stuffs again. So from here you can see what I was explaining. Var1 equals to list. We have done all this. So next I want to show you odd, because looks like I missed odd. So here is odd. Odd just does the opposite of what CHR does. Like from our table here, you see now, you see odd, for example, we can want to know the decimal represent. It's very important for those doing into electronics and all this stuff. They use this a lot. You know, if you are dealing with models and embedded system devices, you do a lot of this. So, for example, the at character, let's see, if you type odd at, you see here you can see it's 64. So our result should be 64. Yeah. Let's see capital M gives us 77. As you can see, M here 77. Let's see breaks braces. So you can see it gives us 125. And if you say CHR 125, it should give us the opposite. It gives us back the braces. So odd is just the opposite of CHR. So I just want you to know that. So I think here should be the end of this video. I think here is the end of this video. We don't have any other conversion to talk about. Yeah, we talked about this dict, how to use a dictionary. You see, dictionary, we have a sequence of pairs 1 1 2 2 3 3. Here is a sequence of tuple pairs. So you see key value tuple pairs. Here is the key value, key value. Now we can pass that to we can use dict to create this. You see, we pass dict a sequence of key value tuple, key value pair tuples. So it's going to create a dictionary with key 1, value 1, key 2, value 2, key 3 as a string, value 3, key 4.5, and value 4.5. So let's see the output of this. As you can see, here is the dictionary that was created. You see this is a dictionary 1, 1, 2, and all those stuff, 3, 4.5, 4.5. So I just wanted to see that. So we are going to look at Python operator next. So see you in the next video. Yeah.